Alright, here on the first one, you got the triangular prism that is 30, 60, 90. So if it's 30, 60, 90, then here I'm going to make this the 30-degree angle, this the 60, and this the 90. If you're going to label according to X, it is most convenient to label the short side X, because then you have 2X for the hypotenuse, and then X square root of 3 for the long leg. That is the easiest, and then of course going this way to give it the dimension, it is Y. So you know, given from the problem, it is volume equals 12,800, and the formula for volume is 1/2 base times small height for the triangle, and then times the larger height of the prism. But in this case, it's 1/2 times X, and then square root of 3 times Y. Now, once you plug in those variables for the volume, simplify as much as you can. You have 2 x's here, so that's x squared, and then of course the half, and then the square root of 3. So leave that alone for right now. You'll set them equal to each other later on. For the surface area, we're going to add up all of the areas of all the sides. So we'll start with the triangular face that is facing us, and that's 1/2 base, which we could call x, and then height, which we could call x square root of 3. Now of course, if you have this for the front face, the back face will also have 1/2 x times x square root of 3. So you have 2 of them. I'll bump this up a little bit more. There we go. Now this one, x square root of 3y, is dealing with the bottom side. It's the outline here on the very bottom. This times this gives us the area of the bottom. And then the xy will give you the area of this back side, because it goes up x and then back y. And then finally I have to scroll over this way. There we go. 2xy. Here's the 2x and then the y. That's for the slanted face. 2xy. All of this should be simplified. If you try to do any kind of a derivative or anything of that sort with this, in this form after you plug back in for y, it's not going to be pretty. So here we have this. We can simplify the x times x in this one and this one to get x squared here and here. And then over here we can just leave this the same for right now. But you have xy plus 2xy. That would be 3xy. Now back here, we can go down one more step. You have a half x squared square root of 3, and then a half x squared square root of 3. Half and half is 1. So you just have 1 x squared square root of 3. And then for this term here, put the y out with the x. xy square root of 3, and then of course this stays the same. That is the simplest form we can come up with right now. So move to the volume formula and set it equal to 12,800 and get y by itself, which means this is divided by a half x squared square root of 3. Now dividing by a half is the same as multiplying by a 2, so get rid of this and multiply the top by 2. And you'll have 25,600 over x squared square root of 3. Alright, so plugging it in for y. We have 25,600 over x squared square root of 3. Here it is. It's going in for y, and don't forget what the formula was. Here is the formula here, so it's going to go in this spot here and here, just those two places. And this is what it looks like when you plug it in, here and then here. This front part can't simplify, but you have square root of 3 over square root of 3. Those cancel out, and x over x squared leaves you with x. And then on the back side here, you got to multiply by 3, so that's where we get the 76,800. X over x squared is x, and you have to keep that radical 3. Okay, so we end up with finding a derivative of what we just had. Don't forget that you have to change the sign, add 1 to the exponent, and then the top is going to stay the same when you start with an x to the first power. So the bottom goes up by 1 on the exponent. Notice the square root of 3 stays the same. And then with that derivative, you have to set it equal to 0. And what we can do is multiply by x squared to get rid of these x squares on the bottom. When you do that, they are now gone. You still have this on the bottom here, but that's no problem for right now. So bump this stuff over to the right, and you'll come up with this divided by the 2 square root of 3 that was with the x cubed. And then, of course, this is your x value. You can test it with the second derivative. It does come out positive. And now you have to solve for y. So plug this back into the volume formula. Divide 12,800 by 1/2, this quantity squared, and the square root of 3. And come up with 19.9337. Now for the homework problem, you just need to find the volume of this triangular prism first, which is pretty straightforward, 1/2 x squared y, and set it equal to 840, divide by 1/2 x squared, and it's 1680 over x squared. So you're going to use that a little bit later on. The surface area is much easier than the 30/60/90. You just have the bottom, the front slanted face, the back, and then the 2 triangular faces. These are the triangles. This is the bottom and the back, and of course this is the slanted face. It's y by the hypotenuse. Hypotenuse is square root of x squared plus y squared. That's a nasty looking y squared here. Oh no, that should be x squared, isn't it? Yeah, that's right. That's my fault. I thought I was supposed to have a y there. That's x squared plus x squared. That's right. Can never tell with my handwriting sometimes. Alright, so if you simplify that, 1/2 and 1/2 is 1x squared, and then 2xy is this, and add those together to get 2x squared. And then simplify it down to this plus this, and remember x squared simplifies out to just x, because it's under the square root sign. Now you're going to have to plug in this value from up here, where we solved for y, into this spot and this spot. When you do that, this is what you're left with, and you have to find the derivative of it. And you have to change the sign, increase the exponent by 1, and then the old exponent times the top, which it was 1 to start with, so it doesn't change. So now you have to set it equal to 0. The derivative is equal to 0. Multiply both sides by x squared to get rid of this and this. This is what you get. And then to move this and this to the right and divide by this 2. You should come up with 14.2077. And then if you go back and find the second derivative, it is positive, and plug in the value for x for the y formula from the very beginning where we solved for y. It's from the volume formula, 8.3227. This is going to be a practice problem, and it's going to be a cylinder. Of course, a cylinder has a top and a bottom, but in this case, this one will have no top. The volume of this cylinder must be 960 cubic inches. So what we are looking for will be the dimensions that will allow us to have the least materials used for this. Alright, to start off for this, you're going to have the volume formula. So the volume of this can, we're going to make the radius x, We'll write it at the top even though there is no top in the problem. But the radius x and the height y, so the volume is pi x squared y for the cylinder. And then for the surface area, you're going to have not 2, but you're going to have just 1 pi and then x squared. That's one surface area for one base, one circular base, and then plus the area of the lateral surface around the can. And of course that's going to be the height times the circumference of one of the circles, so it would be 2 pi x and then y out on the end. We do know that the volume is equal to 960, so with that we can set pi x squared y equal to 960. And then divide 960 by pi x squared and plug that back into the formula. So 960 over pi x squared is what we need to look at next. Alright, so the surface area would be pi x squared and then plus 2 pi xy, which of course we're plugging in 960 pi x squared. 960 over pi x squared. So you'll have pi x squared plus 2 pi x and then times 960 over pi x squared. When you go back to simplify that, it's pi x squared and then plus 1920 over x. And then when we find the derivative, it'll come out to be 2 pi x minus 1920 over x squared. So you have to set that one equal to 0. So 2 pi x minus 1920 over x squared equals 0. You can multiply both sides by x squared, and it will cancel this out. I may have to zoom in here a little bit to try to finish this off on the same screen before time runs out. Or I might be able to fit it in, but it would be 2 pi x to the third and then minus 1920 equals 0 when you multiply through. So from there you can solve for x by moving the 1920 to the right, dividing by 2 pi, and then finding the cube root. You should have 6.7356, as I say over top of the bell, 6.7356, and then when you plug it back in, what should you come up with? 6.7355? Because the class change is taking place now while the video is going on, so we'll have to finish quick.